What I want to talk about today is around how Betterview is using drones combined with AI to scalably inspect buildings and properties. And we're mostly doing that for the insurance industry. So I'm going to go into examples of what are the challenges that we run into, what do our customers run into, what do they really need, and how are we using kind of a combination of drones, which is going out and capturing a lot of imagery with AI to be able to analyze that imagery. As we're moving all beyond proofs of concept and into real scale production use of drones across a lot of different commercial industries, insurance included, there's some real considerations that come up. So my background as co-founder and CEO of Betterview, started the company about 3 years ago with my co-founder Dave, who's in the back. And my background is in the is really on the kind of enterprise software side, the technology. So I was flying some drones around and found out that Dave was actually trying to solve a very specific problem, which I thought, we should go out and see if this is a real thing. Can we actually use drones to solve the problem? What Dave was dealing with was he grew up his whole life, before we were born, his dad started a commercial inspections business for the insurance industry, doing pre-loss inspections. So an example would be like this property, right? So they have a network of individuals who are trained inspectors who would show up and they would look for all the life safety systems. They'd check the sprinklers out. When's the last time they've been inspected? Were they functioning? Electrical panels, are there any that are high risk, that are dangerous? But one of the things they were missing out on was really good roof data. So in the US, in property claims, we talk to our customers and we hear somewhere around 30 to 40% of all claims are roof related. So what that means is the roofs themselves are really expensive to replace, right? But the problem you have is that you also have loss of business and you have the loss of content. So the dollars that are getting paid out are really significant, and they just weren't able to provide really good data, in part because getting access is one of the issues. These are kind of two extreme examples. This guy's breaking tiles as he's walking around on this roof on the right. We have customer Church Mutual that we fly churches for, so the steeple and just the roof structures are always very challenging. But we also have just even one-story buildings, two-story buildings. You can have all kinds of access issues. And so we've decided, let's see if DJI's drones were an appropriate way. We started out 3 years ago with a variety of different ones, but now we're 100% DJI. We support a whole lineup. So, the nice, and I imagine most of you are, have some experience with these hardware devices as well, all the way down to the Spark. Our software supports all of it. These things are great. They go out and they start capturing either video, or in our case, continuous shot still photos. And so what do we do with all that data, right? So it's like we can go out and capture anything we want. We can keep putting the drone up in the air and capture an infinite amount of data. But really the issue comes down to what do we do with all that imagery, right? So how do we actually derive real insight off of that? Here's some great photos. You look at these things and there's some real information value in there. What we found is, to give an example on commercial claims, a typical commercial claim, we're capturing 700 photos. Right, so we're doing that with a Phantom 4 Pro, then you're talking about 10 megabytes per photo. You kind of can do the math. You got 7 gigs worth of data. And storage is not a problem, right? It's fairly cheap, but how do you actually derive any insight off of that? So kind of the first question is, what are our customers actually trying to determine, right? And so here's some examples. Our customers ultimately, why do they buy from us? They don't care that we're using drones. They want to be able to know, is there hail damage? Is there wind damage in the form of missing shingles? Ponding kind of shows you, this is a flat roof with ponding. Basically, the roof starts sagging, shows that it's end of life. And they don't want to be on the hook for a major hail claim. And by the way, they also want to be able to solve problems proactively, like debris. Cleaning debris out is really cheap, but if you don't identify it, you don't clean it out. And the problem with it, this is an example on a steep slope roof. It's even worse on a flat roof because if you get all the drains blocked up, big rainstorm comes or a lot of snow and it can't clear out, the roof can collapse, causing loss of life and a significant amount of damage. So these are the types of things that they want to know, right? So we can go capture 700 photos. Great, they want to know this, and in significant detail. So we're working, so just real quick, to kind of explain within insurance, who are we working with and how are we working with them and why. And so it's property insurance. It's really US based for us right now because of the regulatory environment. That'll expand over time. But it's underwriting and it's claims. So on the underwriting side, this is an example of an output that we generate. It's all based off that imagery we capture, but it gives you a really quick, this is an example of a 6-building multifamily complex. And we're able to say, you know, the roofs are in varying levels of condition. We had a bunch of issues that got highlighted. We generate a rec sheet, so this is really helpful to say, okay, you found all these problems, you know, what are we supposed to do? So, and then historical weather, by the way, is also helpful. You know, there's a 3-inch hailstorm. It had up to 68-mile-an-hour gusts on this property. So these are things that, you know, we should be looking out for hail damage, and we should be looking out for wind damage as well. Probably not severe, but you know, you get the idea. Claims is very similar. We need to detect what the condition is. But I guess in addition, so underwriting, we need to know the condition. We need to be able to identify the damage spots. You also, in claims, need to be able to create the dimensional measurements. So our customers ultimately want us to package that up very nicely so they can either make a very quick. So they don't want to take a whole bunch of extra time in their underwriting process. They don't want to take a whole bunch of extra time. They want to take less time in processing a claim. Be able to provide more data. So, you know, at this point, we've now analyzed over 13,000 buildings. We've generated 1.3 million photos from doing that. And all of those photos have been looked at by claims adjusters and some other forms of experts, primarily claims adjusters, to identify damage. So we built a tool well before we had our AI 2.5 years ago that allows somebody to go through a set of photos and who is a trained eye, an expert, and be able to start annotating, right? So draw a box around the things you see. And so from that, we ended up creating about 87 standardized issue types around roofs, and we have some other tag sets as well. And so what that was the kind of foundation. What we realized is that we created a process where AI was very relevant. So if a big part of our process is look at photos, identify one of 87 different things that you know of ahead of time, machine learning is a great application to use there because you can teach the machine to do it. And so we think about this in terms of a positive feedback loop. I was an electrical engineer, and so we think about positive feedback loop in an amplifier, and we got the same kind of thing here, which is we go out and we collect and we input the imagery into our machine learning system. Machine learning system, we always do pre-training on it. So on hail, for instance, we threw some imagery in it and started tagging up an initial data set to find, to basically prime the pump, right? But
it's essentially supervised.
What's that?
Is it essentially supervised?
Yeah, it is supervised. Yeah, absolutely. Yeah. And it continues to be. So what we do now is after you do the pre-training, we then send more imagery in. The machine makes a prediction, and then we still have a human expert then looking at those predictions and fixing them. And the reason we do that is twofold, right? So first of all, that gives us a image that we can then use in a report we can send to a customer, and they pay us for that, right? Which is nice, right? So that's a useful output, and it's even better than the ones we were creating before when there was no machine learning involved. But that also is then feedback back into the machine, which it then can use to learn further. So this is an ongoing iterative loop because this learning piece of it doesn't happen instantly. It takes a lot of computation. It takes time to do that. But once it does, now it has a smarter model, has a better learning model, which then you put you go out and collect some more data on some new properties, some new roofs. You push that imagery data in. Once again, it makes new predictions, maybe a little better than they were the previous time. You provide feedback and correct those predictions, have usable photos. It learns again, it generates the model. So we kind of think about this as a continuous loop, but a good one, not an infinite loop. But what we've done, so hail detection is an example, one of the more complex ones, where at this point we've done this 20,000 hail photos. And the model's regenerated itself over 1,000 times. So that's, it takes time to do it. There's other things that are a little easier, that are quicker to discern. And I think about this, I have 2 young children. I have a 1-year-old and a 3-year-old. And I'm thinking about my daughter, over the last year or so. She was able to, early on, identify that that's our car, right? So you go up to it, it's like, oh, it's a white car. I recognize it. And then you actually eventually realize that she'll see other cars like your car. And she's like, oh, there's another white car. There's another white car. And so I'm thinking now she just knows that they're white cars, but she's starting to pick out the same model. And then eventually, when I found her, she'd go, oh, Daddy, there's a red Golf. I go, oh, okay. So she was able to actually take the same vehicle, figure out that it was the same type of car, even though it was a totally different color, and it was just driving down the street. And that's how we've seen these things. I'm like training, a toddler at the same time we're training machines. But it's like very much the same principles apply, right? And it's a lot of corrective. So over time, as she figured those things out, over time she would ask me, like, is that a car? Is that this, is that? And the answer is no, yes, back and forth. But the machine learns kind of much the same way as a toddler, if you think about it. So anyway, this is the same image on the left and the right. What this, and without the machine learning, this is really cost prohibitive. Sit there and actually pick out every little hail game. But it is helpful because now I can actually quantify the extent of the damage. Customers love it because they can actually see where it is. Instead of being very quantitative, we can get very qualitative about it. And so we have, by the way, this is hail damage that has, hail doesn't just fall straight down. It usually has some wet, serious wind. So you actually end up damaging facades in addition to rooftops. And so, our flight patterns capture that as well. So here's another photo, right? So everyone looks at this, kind of hard to see, there's maybe some hail damage in there. It's harder to quantify. Same example, so it's overlay on top, and this is what the machine's able to find and show us really clearly. So this photo is much more powerful than just having a box over it saying, hey, there's hail damage on this roof. This is one of the big things that the machine learning buys us. So in addition to object detection, we're also doing classification. So it's just, is there the presence of something in the photo? Here's a bunch of different things we're looking for. BRRR stands for built-up roof. It's just kind of this roof type over here. This is a mixed roof where you have built-up roof over here, and you have a metal pitched roof here. So we have, with high confidence, we have a built-up roof, we have metal roof, no wire, no debris, no visible hail damage. So these are the types of things that we're able to. These are all questions in our reports that we've had humans filling in, and now get the machine to kind of do the less interesting. It's not like it's just purely like is this present? Is it not? In terms of how does this all fit together, and having a more deep explanation as to what should the course of action be. Still very much relying on humans to figure that part out. But we're saving them a whole lot of time, and ultimately we're a lot more accurate. And this is kind of what this is on this roof type system. This is kind of what the training looked like, where you start out with no confidence. You throw some data at it, and you actually go and answer manually all these things, and then it goes and builds some models. It starts making predictions. The confidence is high, and then it drops because it realizes it made some really bad choices. And then you see that pattern play out several times, and it starts getting less pronounced, right? And then you're seeing things kind of stabilize, and you get a really high level of confidence. This is really where it's pretty much you try to use machine learning in this area without serious supervision. The customers will be very disappointed in the results they get. But once you get up in there, the goal is really to get as high to the highest level of confidence you can, so that you're outperforming humans over time. So I don't know if I need to really even go over all this, but what are the benefits? I've talked about a lot of it. Really for us, it's a question of the last, in the first few years of business, really working with our customers as insurance carriers, and we're working with other vendors in the ecosystem, like claims management companies and TPAs, and also inspection companies. But really, they were kicking the tires a little bit, and scalability is not a problem at first, but as you start trying to do this at really larger and larger scales and volume, you need the assistance of the machine to deal with the mountains of data that we're generating with each inspection, each job. And over time, that drives greater cost effectiveness, and the depth, I think, is the other thing I really like, which is what I was showing on how we can actually pinpoint and quantify the data in a way that's just really not cost effective and possible to do before. Just real quick, I was going to give a case study. This is a typical type of property. We do single structures. This is an example of a 30 building structure. You can see that this is the ortho map on the left. It's green because we have our a property line overlay on top of it. But what we went in and did for this customer, they had a claim. A hailstorm came through. So legitimately, a hailstorm came through and it damaged the rooftops. So typically what you're going to have to do is get a claims adjuster to climb every single one of those roofs, or he's not feeling particularly diligent, climb on one, assess, yeah, there's hail damage, climb on a second one, yeah, there's hail damage here, you know what, I bet the other 28 have hail damage as well. Let's just go ahead and, let's just adjust this sucker. Well, we don't do that. We look at every single one of the buildings in great detail, because we can, and we can do it very cost effectively. And what we found in this scenario, in this particular case, was that about half the buildings, the roofs were damaged, needed to be replaced because of the hailstorm. The other half were not. And we had the visual record to prove that. I mean, obviously, when you go out to the customer, you say, "Hey, we're going to replace 15 of your roofs, not the other 15. And here are the ones. You better support that with some data." But as a result, they avoided an unnecessary roof replacement on 15 structures, and that was $500,000 worth of hail. So this is why we talk about drones. We think about it's pretty obvious. Like, it's safer than putting a person up on a roof. We know the safety hazards. It's quicker, but really the end game here is just more data value, right? And it's by nature of it being quicker, it actually allows you to surface a whole lot more data than you otherwise would have. And that's the real win, right? And also with the AI, it allows you to surface insights off of that raw data in a way that otherwise is infeasible. Pretty close to wrapping it up, and then I'll open up for questions. But as an example of the type of companies we work for, I mentioned Church Mutual earlier. These are the ones that are on our website we're allowed to talk about. I don't know, if you're in the insurance industry, you might recognize some of these names. But some of them are, like, one of them's owned, USLI is owned by Berkshire Hathaway and Redwoods, and so Redwoods is owned by the Fairfax, which is the Canadian equivalent. But so there's a lot of the mutuals, mid-sized companies. We don't have the logo up yet, but we're allowed to talk about AIG as well. So now we're seeing the big carriers. They were a lot slower to buy, and we're seeing them actually get out and do this stuff in production. So the CEO of Travelers Insurance had their quarterly earnings call a few weeks ago and said that they're scaling up their operations so that they're going to have 650 of their employees equipped with drones out in the field and doing both risk engineering and claims. So that's going to be by mid-2018. So we're really seeing real adoption well beyond the innovation teams and the proof of concepts at this point. So that's very exciting. The way we've been engaging with these customers is we've been providing them our platform, software platform. That's actually more recent for us. The way we got started originally, primarily because of the regulatory environment, pre-Part 107, was we spun up our own pilot network, and still a very valuable part of our business. And so we offer basically our whole process. You can get the report output by just provide us an address and ideally contact information for that address. Sometimes we have to go searching for it. And then we'll get you that report. We'll get you all the analysis. What we are really proud to announce today is, based on customer feedback, we are now offering a third way, and it's this thing in the middle of the ready-to-fly kit, is what we're calling it right now. But it's basically what it is. We found from customers that they can go to Amazon or the DJI.com website and they can buy drones. We have a variety of options. But the challenge they're running into is, especially the big enterprises, what do we do if something breaks? What do we do if whether or not they broke it or it breaks on its own, it doesn't really matter. They need an easy path to resolve that. And so what we're offering now is a seamless experience. We have them covered all steps of the way. We will handle all aspects of it. So it's a combination of leasing, includes our software, includes all of our training. With this pilot network, one of the great things that's taught us over time is how to train a bunch of people. We've had thousands of pilots sign up. We've worked with hundreds of those on jobs, and as a result, we know how to vet them and how to get them trained out. So, so we're excited to offer that out to the world, and that wraps it up for me. But I want